All right, let's get started then. Okay, thank you for joining us today for an Ask Me Anything session with three of our principal engineers. This is a chance for you to get to know more about AWS and get the inside track on what it's like to be a principal engineer at AWS. We'll begin with introductions, then we'll kick off the Q&A session with some of the pre-submitted questions, and then afterwards we will take questions from the audience. This is an open forum, and I encourage you to jump on video to ask questions. You can also submit questions via the Chime chat window, too. OK, so I'll kick off the introductions. My name is Danny Wei. I'm a longtime Amazonian. I've been with the company for 15 years now, starting off as a college hire on Amazon Prime. I then spent about a decade working on Elastic Block Storage, and for the past 2 years, I've been working on the Snow family, a series of disconnected edge compute and data transfer products. Okay, so Neil, can you introduce yourself?
Yes, hello. My name is Neil Charbonneau. I'm a principal engineer on the Elastic File System team. I've been at AWS for a little over 6 years. I work mostly on our access layer, so think NFS protocol and our distributed file system implementation.
Oh, Steve?
Hello, yes. I'm Steve DeVoe. I joined Amazon about 4 years ago, and we started and built AWS Backup, and look forward to talking to you more about that.
Okay, and then also here with us is Jennifer, Kelly, and Rowena, who put this together. Can you three jump on and introduce yourselves also?
Oh, hi everyone. This is Rowena Sang, and I am a principal recruiter here at Amazon. I've been here for 6 years. Nice to meet you all.
Go on video for a second, but this is Jennifer. I'm also in principal engineering recruiting, and I'm really excited about our AMA session, and it's great to meet everyone.
Get my video working. My name's Darby. I'm also on principal engineer recruiting. Super excited about this session. We want it to be really truly an informal and organic discussion. So again, just to reiterate Danny's point, hop on video if you want to ask a question, drop it in the chat box. And I will also drop in an email if you guys want to connect afterwards. You guys can send me a note. Thanks.
Okay. Cool. I will. Let's go ahead and start the Q&A session. We'll start off with 3 of the pre-submitted questions we got. First one, it will be for Neil. What are the 3 architectural design challenges when you designed Elastic File System, and how did you solve them?
All right, I'll try to keep this sort of as short as I can. We can talk about this all day. So, I mean, one of the things, I'd probably start with elasticity. So one of the things that customers really like about EFS is that you both pay for what you use in terms of storage. So there's no limit on what you can store, and you only pay for what you're using. So elasticity in storage, and also elasticity in throughput and IOPS. So there's no pre-configuration, no setup. It just sort of scales to however you need to use it, and you pay for what you use. That's a nice customer experience, but it's also really challenging to build and design. And there are many aspects of how we did that. But one of the things that we did that was pretty interesting was we ended up building our own custom storage backend from the ground up. So you can sort of think of it as a multi-tenant distributed block device that we can grow and shrink independently of any file system, and file systems will share that storage pool across in this single namespace. Obviously with enough safeguards in terms of security and isolation between customers there. But that custom storage layer really allowed us to scale out, so file system can then allocate and use blocks across a wide range of disks to get that high throughput. And since we're sharing storage like that, that makes the cost model work. So customers can, as customers add and delete data, other customers can come in that same shared storage pool. So that was sort of one of the key aspects, key pieces of EFS, how we solved the elasticity problem, and made a good customer experience there. Now this introduces more problems that you have to solve. So file systems typically, want to modify multiple disks at multiple blocks at a time when they make a mutation of the file system. So now we have this big distributed block store. How do we do that safely? And also, more importantly, how do we make it so that that's easy for developers to use and get right? So here the underlying mechanism we came up with, we basically have a modified two-phase commit that allows you to atomically mutate multiple blocks. So that's the mechanism we built. But more important, or just as important, is the interface we put on top of that. So the intent was that we would build this thing once, harden it, it works. But people are going to be changing the file system all the time for new features. So we want to make sure that API was really simple to use and sort of misuse resistant. And we think we accomplished that. And what it looks like, as a file system developer, you can't really tell that you're dealing with a distributed backend. All of that complexity around all those different faults in terms of disks or networks or whatever is completely hidden from you, and you have this nice simple API to use. So those are a couple topics around sort of elasticity and distributed storage and how we deal with that. The last one I'll cover briefly is how do you build a general purpose file system? So a file system means lots of different things to different people. Different workloads have different performance or feature requirements. So how do you make, what is a general purpose file system? And the things I talked about previously work really well for scale out. So if you want high throughput, high IOPS, we can sort of distribute them well across all these disks. But there are obviously lots of file systems that don't need that scale out and want lower latency. So the way we solve this particular problem is that we can sort of introduce a new component in the stack it sits between the file system and storage that provides journaling and caching. So it's it fits in pretty nicely to the architecture, doesn't require changing either the two layers above or below it, and provides these lower latency with those two mechanisms. So those are the three big things that came to mind. I'll figure out how to share a link. We have published a lot more detail about these things, so if people are interested to learn more, you can do a deep dive on that.
Okay. Thanks, Neil. Another one of the pre-submitted questions is, will you consider persistent memory, e.g. Intel Optane, or in your future designs? What is the impact of those big memory systems on your designs? I'll take this one. Okay, so we are always looking at the latest technological innovations and how we can incorporate these designs, into our designs to provide value to our customers. The standard way to think about different types of storage technologies is that you have cheaper, slower storage systems, and as you go into the more performant, faster ones, such as storage class memory or persistent memory, they tend to be a little bit smaller but much faster, and you can always use them for tiering solutions. However, with persistent memory or storage class memory, we get some very interesting properties in that we now have extremely fast random access storage that is persistent and durable. Even with current flash technologies like NVMe or your standard SSDs, there's still a fairly large performance difference between sequential and random access patterns, especially for write. Therefore, in a lot of our storage designs where we use things like trees or indexes, we tend to serialize these into journaling or logging structures to ensure that we keep a sequential write pattern for higher performance. And these things require us to do things that are slightly inefficient, like checkpointing or employ copy forward mechanisms. With persistent memory, we can now store and work on these data structures in place, which can increase the efficiency for use cases like indexes and the like. Okay, next question is, what was the most challenging storage-related issue you have experienced in Amazon scale production? Neil, since you've worked on EFS for a long time, I'm sure there's quite interesting issues you've run into there.
Sure. I guess the one that immediately pops into mind there is we I'm a software guy, so anything dealing with hardware is challenging to debug for me. So we in one case that I remember pretty clearly, we had a latent bug in the NVMe SSDs we were using, specifically in the firmware in the flash translation layer. Where so internally in the SSD, there's some background workload to do like garbage collection and wear leveling, in addition to the foreground requests that we are sending the drive. And there's a bug in this device that would sort of incorrectly start throttling the foreground traffic too early. So it looked like for us is that we get great throughput or I/O to the device, and all of a sudden it dropped to basically nothing. And what made this particularly challenging is that it was a latent bug, so it only happened, and it only happened once the wear leveling traffic got above a certain level. So what this looked like is once drives reached a certain age, vintage, seen a certain number of IOs with particular IO patterns, we would see this bug where throughput would drop for a short period of time. So that made it very difficult to debug because it only happened on certain drives and certain that have seen certain traffic, and it wasn't really any changes we made. So it took a long time to sort of find that. And then also, working with the folks that own the drive and going through those layers of the stack to identify where exactly this was happening was a challenging and fun experience.
All right, let's open it up to the general audience for some questions. Feel free to pop onto video and ask your question, or type it into the chat box here too. All right, so we have a question here. Any challenges with multi-protocol support for EFS? Neil, I'll let you field this one.
EFS, so we do support two access mechanisms today. One is the NFS protocol, and the other one is we recently launched transfer support. So it transfers another AWS service, and they support SFTP, so you can use that and hook that into EFS. So we don't really support, I assume by multi-protocol you mean maybe like SMB or object. EFS doesn't support that today, so if you have a follow-up, I can answer more, but we don't support the protocol in that sense today.
All right, I have one for you, Steve. How does your work impact your customers?
Excellent. Yeah. So today, customers are looking for a way to bring their on-premise applications that they've been used to backing up with these third-party backup solutions to manage their compliance. And they're looking for a way to bring those into the cloud using cloud resources. And so we created AWS Backup, focusing on the customer need to be able to back up cloud-like resources, things in RDS, EFS, EC2, FSX, and back these things up in a manner that was consistent with the expectations of on-premise backup solutions. We have frequent conversations with our customers diving into exactly what they need. We're a new service, just started from nothing 4 years ago, launched just 2 years ago. There's a lot of functionality that we need to add, and prioritizing that while trying to create a solution that is simple to use, because one of the biggest concerns customers have is the complexity of using a backup solution. Some solutions require you to be a certified administrator, taking a lot of time. We're trying to create something simple to use, which is very customer focused, as opposed to just exposing the options of all the underlying services that we manage.
Okay. We have another question. Principal engineer means so many things to different people and companies. Can you tell us about what it means at Amazon and your typical day? I think we can all answer this one, so I'll start off with Steve again.
Sure. So At Amazon, as a principal engineer, I am working with many different teams. Right now, the number of services that we support with AWS Backup is limited in comparison to the number of data stores that are provided through AWS. And I am working with the various service teams, trying to identify how and when they can onboard to AWS Backup. As you can imagine, every data store has its own peculiarities, and how those peculiarities will interface with AWS Backup.
Neil, do you have anything to add to that?
So yeah, I mean, I think being a principal engineer at Amazon your role changes depending on sort of what's going on at the current time. Are there new projects starting? Are there integrations? Are there challenging bugs? So you wear different hats at different times. But I mean, in general, I'd say the principal role is sort of the you're part of the leadership team. You're providing technical guidance. You're looking around corners. You're setting best practices. All of those sorts of things. So you get to see sort of the big architectural picture, but you're also still getting your hands dirty. Principal engineers still write code, still deploy code, still do operations. Yeah, I think that's the bit I'd add.
Okay. Yeah. I'd like to echo that also. Principal engineer to me means essentially providing technical direction, technical leadership, looking at opportunities that are coming up, looking at issues that we have, and how we can address them, balancing new features, balancing operations, also looking at different areas outside of what we are immediately focused on. To make sure that we are looking around corners, looking at opportunities to do integrations, looking at opportunities for partnerships, looking at how we can leverage different and interesting technologies that we may not be thinking about just yet. So a lot of teams tend to focus a lot on kind of their own roadmaps, and as a principal engineer, we are expected to have a more broader view to look at other teams and other organizations' roadmaps and see where are good intersection points, how we can share and leverage each other's ideas.
And one thing I have found at AWS is that almost every principal engineer I've talked to has found and created a unique role for themselves. Each team at AWS has gaps in the team that they have, and the principal engineer, whether filling the gap in that might be there from SDM or from a PM standpoint, or obviously filling the SDE holes that need to be addressed. It really is a fun role because you get to define what you're building and how you're managing your time.
Okay. How do you share ideas across teams within AWS Elastic File System and across Amazon? We'll start off with Neil here.
Yeah, I mean, so I guess this is more specifically across. For principal engineers, I guess, since this is what this AMA is, there is a principal community within Amazon. That's a really great way to sort of get a sense of what's going on across the company, share ideas. There's a weekly lunch. So that's a nice way to talk to people sort of across the company and figure out best practices, what's working, what's not working, get a nice broad sense there and share ideas. Within EFS, yeah, I think that the standard things, brown bags, we do incident reviews to make sure we understand the system and learn and get those lessons learned there. Yeah.
Okay, next question is, EFS has had wide adoption over the last year. As a member of the team, what have some of your challenges been taking on that customer load?
Yeah, I think the really important thing there is to stay on top of operations and making sure that that's sustainable. As we grow, we get more users, we have more software running, more hardware running. So making sure that your automated systems continue working, so you don't have to wake people up at night. That's certainly key to growth, and making sure that you're learning lessons there and continuously improving. So I think it's a combination of monitoring and continuous improvement there to make sure that your sort of infrastructure can scale with your users, so that you're not burdening your team and developers, so that they can continue innovating for the customer.
Okay. Let's see here. Next question is, can you talk through AWS's end-to-end process from ideation to launching a service? Steve, can you take that one?
Yes, happy to. So when I started at Amazon, we had an idea that we had this wonderful Glacier storage, and we were wondering why it wasn't used more for backup and recovery. And we started thinking and drilling into that and talking with customers and partners, trying to understand the problem. And as we dove into this, we realized that customers were less interested in necessarily the storage, but just being able to manage the backups. So what started out as designing a storage tier that was optimized for the backup use case evolved into creating a backup solution itself. And that happens at AWS. We work backwards from the customer, and in some cases, we look at how we see customers using AWS and take guesses of what problems they're encountering. We go and we validate that, and as we learn, we evolve the solution that we build. And in this case, starting with one idea, moving to creating a backup solution, talking with customers, building out something that solved the customer's problems, which was specifically, how do I move my services to the cloud to use these wonderful AWS resources if I can't back them up, if I can't have the type of management that I'm used to, and I can't comply with the requirements that we have. So it really, it's very customer focused. It evolves. It is flexible, and it's where you end up is a mystery. It's a fun challenge. You just keep iterating and diving into the customer and getting their feedback.
Okay. And the other questions along similar lines is, at the scale Amazon is growing, innovation continues to evolve. How do you approach risk versus reward when it comes to innovation and improving the customer experience? So I'll take this one. Our high-level process here hasn't really changed significantly in the 15 years I've been at Amazon. We always start with the customer and then work backwards, very similar to what Steve just said. And And 90% of everything that we do is a direct response to customer asks, and the remaining 10% is inferred from customer asks. The key aspect here is incremental delivery and being agile. So when we launch a product, we launch with what we define as an MLP, or a minimum lovable product, which is slightly different than a minimum viable product, where what we want to do is we want to launch with a minimal feature set that will still delight our customers. And the other big and interesting thing is that our customers are very innovative. They will find ways to use our service that we haven't thought of. Therefore, we usually put in place strong monitoring and metric systems that allow us to gather feedback on our customers and how they use our service and what they are looking for. And this helps us determine where we can deliver additional features to improve their experience, to make their lives easier. This allows us to be agile and to respond quickly. It doesn't mean that we build a perfect service, but it allows us to quickly respond to issues and to be indistinguishable from operationally perfect. Okay. Do we have, we're almost out of time now. Do we have any final questions? Okay, then. So let's see here. Thank you for joining us today. We'd love to hear more from you. And if you have any additional questions, you can reach out to Darby or Kelly or Jennifer here, and also the email address that Darby provided, and they can direct the questions to the right person to answer it. Thank you, everybody.